Hello, everybody. My name is Zorz. I'm from Internet Society. I come from Slovenia. Thank you for inviting me here to Georgia. My presentation is a little bit longer than usual because your great program committee asked me to add some stuff at the beginning to explain a little bit more what is NAT64 and how it works. Right, so here we will not discuss IPv4 at all. Okay. So, what is the problem? So let me walk you through all 6 degrees of my inner turbulence. IPv6 and IPv4 are incompatible on the wire. They can live on the same network. You can deploy dual stack, but they do not know about each other. They do not talk to each other. Different addressing, different ether type, different packet format, completely different, like 2 ships in the night. They don't see each other. So, we need transition and translation mechanisms between the 2 protocols. Because some people started deploying IPv6 only networks. Having 2 protocols on your network costs you money. It is more expensive. So some people started saying, okay, we want to disable IPv4, and they are actually building IPv6 only networks. I've seen also presentations for data centers. They are just giving IPv6 addresses on the servers when they are selling virtual machines, and then translate them on the edge through basically one IPv4 address, so people on the legacy internet can access their services. And that works. That's the today reality. So, for example, T-Mobile USA, I think they have more than 100 million mobile phones on IPv6 only. These phones sometimes also need access to IPv4 content. And then they put this NAT64 translation device in between. Also, some people does weird stuff. In IPv6, you have, instead of A record in DNS, you have Quada Records. And people put really, really weird stuff in there as a field. I will show you later. So, important question that I was thinking about was, do content providers know how their content will be seen from such environments, from NAT64 environment? And do connectivity providers know what their user experience will be on IPv6 only? Okay, let's go through some dark magic behind NAT64 DNS64 fairly quickly. Do I have a pointer? I do. Okay, so this is the machine that is asking a question, and it's on IPv6 only. It asks the DNS64 that asks the real DNS server. It gets back just a record, and then DNS64 actually generates the IPv6 address. It generates the quad A. If there is no quad A record given back by this DNS server, it generates this is NAT64 prefix, and at the end is the IPv4 address in a hex format. And then this machine establishes the session that is sent to NAT64 translation mechanism, and then this translation mechanism sends over IPv4 to this end device. So here, the network is IPv6 only. Much easier to manage, much easier to control, and much cheaper to maintain. Okay? Everything clear? Everybody understands how this works? It's pretty simple, right? Okay, so we decided, I'm still running the Go6 lab back in home. These are 3 racks of equipment. And we decided to implement and install NAT64 implementations and make them open for everybody in the world that is on IPv6 to test. 4 different implementations, 4 different instructions how to direct traffic there. It's used by operators that want to test remotely. It was also used by Google people when they when they implemented 464 XLET on Android devices remotely to test their code with all possible NAT64 implementations. It is used by hardware and software vendors to test their applications remotely, and it's used by many people. There is quite a lot of traffic to these NAT64 implementations that are sitting there. Here, if you download this presentation, you have a link where there are instructions how to connect remotely to my lab and how to test them. So here are the instructions. As you can see, we have a 10 networks implementation, Palo Alto Networks firewall. That's a big 10 gigabits per second beast. YOL is a free open source implementation of NAT64 that you can install and use. And we also have Cisco sent us an ASR 1K that is sitting there in the corner just for the NAT64 testing purposes. Right. Sander calls this systematic chaos. This is our test lab where this hardware lives. And this is a real hardware. This is not something that is just virtualized and lies somewhere. This is a real hardware, and it's a real testing environment. Okay. Have you ever seen a Quada Records? Yeah? So, have you ever seen people putting in something like column? That's the whole internet. What do these people think? Or column 1, that's just me, that's my local host, that's my loopback address. So if I try to get to the web address that has this in Quada, then I will talk to my loopback. It's nice talking to myself, but it's not very useful sometimes, right? Then we have FE80 and some value. This is link local address. Why putting this out in the wild on the public internet? This is not going anywhere. 649FF9B, this is a well-known NAT64 prefix. This is also not very, very useful. Or 2001 DB8. Who knows who is 2001 DB8? Yeah? Okay. That's a documentation prefix. And just tell me that these people did not just copy-paste from the internet. It doesn't work. So, Dan Wing is doing some periodic testing. There is a link, if he's still doing this, what kind of stuff people put in. You would not believe it. And for these people, if you don't do some exceptions, then if you have users, and if you implemented IPv6, and if you did NAT64 and DNS64, you need to make sure that your users will not call you all the time and ask you about why things doesn't work. Because in dual stack, if something like this happens, IPv4 will carry on and people will get the content and nobody will notice. But in IPv6 only environment, Quada is the only useful resource for the machine. And because there is a Quada record, the DNS64 does not generate the Quada record with the NAT64 prefix, and things stops working. Remember, if you're not part of a solution, you're part of a problem. Try to remedy these things for your users. So, how I did that? That's a piece of configuration code for bind 9. So what I actually did was exclude 0, :/3, so that's the lower part, and I excluded 400, 8000, and the documentation prefix. So what does this mean? If my DNS64 server receives from remote DNS server a quad A with anything that is outside 2000, :/3 that is currently allocated prefix for IPv6, then it just ignores it and creates Quada record with NAT64 implementation. That works. I see Jen is shocked.
No, where is your lead code?
link local should be excluded in 0 colon 3. 0 colon slash 3 is, yeah, okay. And this is also the unbound. I first started, as you see, I first started putting in all the exceptions, and then I decided, no, I will just exclude these outer parts of it and be done with it. And this works. People stopped complaining. Okay, so because of all these things, we decided to create a tool, online tool. It is free, of charge. You can use it. You will see the link later. And version 0, that was basically, I wrote some bash scripts, because my thinking was, how can I test, or how can I enable people to test how their content is seen from the internet? So I created 3 different machines. One was connected to IPv4 only, one was connected to IPv6 only, and one was connected on to NAT64 environment. And I just sent to these three machines a request for a website, and I just saw what I received back and compared. Very simple. If all 3 results are the same, then all good. You're good. If all 3 results compared are not okay, then the content provider that is providing this content needs to do something, because there are millions of devices on IPv6 today only, and content will not be seen from these devices, right? So version 0 was, I wrote some bash scripts, and then I showed them to Sander Stefan, and he looked at them and said, okay, I understand the idea, but please, sir, step back from the keyboard and delete the whole thing, because it was awful. But, you know, I made him, thank you, I made him, I put the idea in his mind. So he wrote the version 1. It's a Python Django application, and Corinne designed the interface. And this was version 1. You see, this is our government.si, and it's all good in all 3 environments. You see, this is IPv4, IPv6, and NAT64 environment. So this content is seen perfectly fine from all possible environments. For example, textfiles.com, this one is not very good, because from IPv6 only is not seen. These people will not see them. For example, this one is even worse. Foxnews.com, they did something crazy, so they are not seen even from NAT64 environment. So these people will not be seen from IPv6 only phones on T-Mobile USA, for example, or on more and more providers that are putting phones on IPv6 today. Version 1 flaws. We figured out through the process and through the usage of it that it was quite unclear what was the failure. Well, it was bad. It has a bad error detection. I could figure out what is the error, because I knew the tool and I know IPv6 for 20 years. But some other people could just not figure out what's wrong. And they were sending me links saying, can you translate this to me into something that I would understand? Then we had 2 different systems that were not connected, one in Netherlands, one in Slovenia. There was no coordination between them. It's still online if you want to test it, but I suggest you better use the new version. Okay, a bit of systematic chaos now. Distributed system, version 2, it's distributed. That means it has one central location with a head. I will show you later. Central web interface, and many test locations possible. It's easy to install if you want to run your own test location. It has better error detection and feedback, and it has the extendability for different tests. So this is how it works. Zaphod is the president of the galaxy. So the component is called Zaphod. And Zaphod talks to trillions. So this is, for example, VM in go6lab.si. This is a VM in Netherlands, and you can connect as many VMs as you want. And we need VMs around the world to connect to this system, so we have as many vantage points as possible to do testing when the test is required. So Trillian is a coordinator, and Marvins are the workers. These are the components that actually sends the request for data, receives the data, and then renders the web page, and then Trillian compares the page and send it back to Zepho that is gathering all the data from all the locations. Quite simple, huh? We have also country selection. So if we get any volunteers from Georgia or from Russia or from anywhere around the world, that would give us a VM to use with this tool, then we would add also a country, and you can select from which countries you want to do the test. It's much better feedback because before when you press the test button, it was just doing the circle. Now it is telling you what is actually doing while testing. Don't frantically press the test button. Press it once and wait. Take the time. It's a process. It's like it can be even 1 minute if things are going wrongly. Okay. Yeah, it has much more clearer summary what is wrong, and much more much clearer output of and interpretation of the tests. You also have a detailed view. If you click on the country, if you click on the vantage point, then you can clearly see, for example, here you can see this is from Netherlands, and the test was on IPv4 was this. NAT64 was just 42% of, because it compares the image. So it was not the same, and on IPv6 it failed completely. It's sort of like a looking glass for you. Okay, we've been through that. You can also, if you create a username and you log in, you can create the recurring tests. That means that you can check your website periodically. So if you have developers that does crazy things with your website, and your website starts failing with this tool, you will receive an email saying, hey, talk to your developers and fix it back. We have some extensive background information. There is lots of information about the failures, and you can go and read why this is happening to you and try to understand what you need to change. Some credits, blames, images and words. Kevin was a project chaser. Technical design was done by me and Sander, and there was also other people that you can see on the slide that were involved here. So, my last slide. Learning to live. Version 2 is out. You can use it. That's the link. Please, go there. If you have a website, go here. Put in just your website address and press test, and it will do the test. And then you can tell me, you can tell me your success rate. We need VMs around the world. If you're running a data center, if you're willing to volunteer a free VM, it's very easy. You just need to install Ubuntu 18.04. It's the supported one. Create NAT64Check user in the sudoers file. Allocate 1/64 for NAT64 functionality, and route it to this machine. Send us the credentials, and that's it. We will then unleash the automation software that will connect to this machine, install everything, update everything, and prepare it to be another instance of this tool. And then we will add it to the list of the countries that has the tool. It doesn't matter from where you are. We don't have any instances yet in this region. And we would be really happy to include you in this open and free looking glass. Many thanks to Internet Society for sponsoring the development of version 2. It was very nice to help the project that is useful to many people. And with this, yes. Are there any questions? Jen.
Да, прошу, вопрос.
Jen Linkova, quick question, sorry if I missed it because I went out for a second. So, are you using the same version of DNS64 for all tests, right? The same resolver?
Yeah.
So, have you experimented with using different DNS64 to see if your brokenness level changes? Because I've seen situations when particular corner cases of DNS configuration was triggering different behavior on different DNS64.
Actually, that's a good question, because different DNS implementations handles differently DNSSEC, and then
there are other corner cases, yeah.
It fails differently. But outside of DNSSEC, do you think that
yes, so
DNS...
we saw case in the right meeting,
yeah.
when some corner cases which are technically correct but kind of outdated, if resolver does not seem to be authoritative for non-existent Quad A, and this case node believes, oh, it's a lame delegation, I'm not going to synthesize. Google DNS64 does synthesize. RFC is totally non-clear on that. So there are corner cases on DNS64 behavior outside of DNSSEC case, actually. So that's why I was thinking it might be really interesting to see if when you change the DNS64 implementation, if you see different type of behavior.
But this sounds like unbound. this behavior sounds like unbound. Yeah, we can. I will talk to Sander. We are open for suggestions also to add new functionality and new tests, and thank you, Jen. Yes?
Yes, hello, Libor Peltan from CZNIC. My question is not related directly to your tool, but to DNS64 in general, because yeah, I'm new to this topic, so maybe I'm just dumb. But I would like to ask about how it's interfering the DNS64, where many users depend on this in America, as you said, versus DNS over HTTPS, which is soon like coming into our browsers, but the DNS over HTTPS cannot like translate those addresses. So where is the problem, and is it a showstopper for DNS over HTTPS?
It's very simple. DNS over HTTPS and DNS over TLS and any other DNS over something of your choice, quick or whatever, breaks NAT64 environment, period. If you are running IPv6 only, and if the developers of the application starts putting in dot or DOH, specifically DOH, this will just break the access for these IPv6 only users.
A quick comment. Actually, nothing prevents your DNS64 resolver to support DNS over HTTPS or DNS over TLS in the first place, right? So you can use this and that mode.
Yeah.
Secondly, I think most reasonable implementation would do NAT64 prefix detection and synthesize. So currently they are using this guessing based on resolving with only address. We have a draft on providing it together with DNS information in arrays. So network could tell you, here is your prefix, do synthesize if you validate in resolver, or if you have to do DNS over TLS. So yeah, you need to guess the prefix if you want to do smart thing with DNS, if you don't trust it fully.
So the proper implementation in my books would be that when you get the DNS information from the system via DHCP or RA or whichever mechanism, you try DOH, dot. If it doesn't work, you resolve back to the normal DNS querying, and then use whatever you got from the network. In case of, I don't know, Firefox or other web browsers that want to implement in the application to use Quad A, Quad 9, Quad 1, this will just break. Without some magic and then tricks and additional mechanisms, it will just simply break.
Okay, thank you both.
Thank you very much.